Hi, I'm going to show you today how to calculate some basic descriptive statistics using Excel on a Mac. Now, if we were using a PC, we would have access to that handy data analysis tool pack. We can do the same thing in Excel, it's just going to take a little more time. So what I've done here in column F is I've noted the descriptive statistics that would be generated using the descriptive statistics tool within the tool pack. And we're going to calculate these. I'm quite simply going to show you the commands needed to do so. Let's start with the mean. I hit equals average, open parentheses. I'm going to highlight column D. And I'm going to tell you in advance we're going to get an error message. And I'll tell you why in a minute. Yep, see that little green flag means that Excel's not happy and we have an error. And the error is because we're referring to empty cells, namely all these cells down here. However, it's quicker to highlight the entire column than to actually highlight D2 to D51. So I'm just going to ignore the error the whole time. Let's move down. Let's skip standard error. Let's go to calculating other measures of central tendency, namely median and mode. Here I'm going to hit equals median, open parentheses, I highlight D, I close parentheses, I hit enter. And let's do mode. Actually, not so fast. So mode is tricky. Mode is a measure of central tendency, but we know that it's possible for samples to have multiple modes. To accommodate a sample having multiple modes, what we're going to do is we're going to highlight several cells in advance. Then I come up here to my formula box. I hit equals mode.mult. I open parentheses. I'm going to highlight column D here. If it would let me, I'll highlight D2 to D51. I'll do it the long way this time. I'm going to close parentheses, and then I'm going to hit Command Return. Now what that does is it generates 30 4 times. This means that in this particular sample, only 30 was the mode. If we'd had more than one mode, it might say, for example, 30, 28, 29, etc. It would list the various modes. So here we've calculated our measures of central tendency. It's important to note that my mean up here and my median are somewhat close to each other because in a normally distributed population or sample, we would expect the mean and the median to be somewhat close to each other. And normality is an assumption of many tests that social workers run, including t-tests and ANOVA. Let's go to standard deviation. It's quite simply equals st.devs. I would choose P if I was working with population level data, but no, I'm working with a sample. So I'm going to hit .s, and I'm going to highlight D, hit enter. Sample variance. Standard deviation and variance are measures of variation or variability. I could get that quite simply by squaring the standard deviation, or I can use the Excel tool. Again, I'm going to choose var.s for our sample. I highlight D, I hit enter. Kurtosis, let's come back to that in a second, and skewness, let's come back to that too. Let's move on to range. Range I'm going to get by subtracting the minimum value from the maximum value. To find the maximum value, I hit equals max. I open parentheses, highlight D, hit enter. My minimum value equals min, open parentheses, I highlight column D, I hit enter. Range equals 36 minus 25, enter, I get 11. Sum, that's not what I want to, equals sum open parentheses, let's highlight column D, hit enter, and count. Count is going to indicate my sample size, and that is equal count, open parentheses. Here I'm going to be particular. No, I'm not. I'm just going to highlight D again. Count only counts the numbers. If I were to hit count A, it should count all my numbers plus my label here in the column, excuse me, row 1. Let's just see. Yep. So use count if you're just interested in the numbers, which we are. There's no reason to count our label. Our label is not part of our sample. So I'm going to delete that. Okay, now we can calculate standard error. Standard error, quite simply, is the standard deviation divided by the square root of our sample size, which is 50. I close parentheses and I hit enter. And now let's go down here to kurtosis and to skewness. Now these two numbers help me get a sense of the shape of my data. If I were to generate a histogram, what would that histogram look like? Let's start with kurtosis, and kurtosis refers to the peakedness or the flatness of my histogram. If the number is positive, it will be relatively peaked. If it's negative, it will be relatively flat. I get it quite simply by equals curt. I'm going to highlight D, close parentheses, I hit enter. This is close to 0, and it's positive. A perfectly normally distributed data set would have a kurtosis value of 0. We have something that's close to 0. Unfortunately, we don't know if this departure, this slight departure from normality, is statistically significant or not. And that's because we don't have a column here that indicates the standard error of the kurtosis. SPSS does generate that, and then enables us to compare the value to the standard error, and that helps us to assess whether the data are normal. We don't have that. We're just taking a guess here that it's somewhat close to 0. Let's lastly tackle skewness. Now, skewness refers to whether we have a symmetrical distribution or a distribution that leans to the left or to the right. A positive value is going to indicate positive skewness. Positive skewness indicates that you have a right tail that extends and it's a little bit longer than your left tail. A negative number would indicate a negative skewness, which would mean your tail to the left would extend longer than the tail to the right. And a perfect value of 0 would indicate a normal distribution, i.e. a distribution that is perfectly symmetrical. Okay, let's hit here. The command is equals skew, open parentheses. I'm going to click on column D. I get 0.288. It's positive, which indicates I have positive skewness. It's very close to 0, but again, because we don't have the standard error of skewness, we don't know if this is a significant departure from the perfect value of 0 or not. So that's it. Thanks so much for hanging in there with me.